Thank you, Ashley. Constraints. What are they? Now, I have a PowerPoint, and if any of you have ever sat in on any one of my webinars, I don't spend a lot of time on the PowerPoint, so don't worry about that. It's just a guide as to what I'm actually going to show you in the software, so you're familiar with what we're going to go over. So we're going to talk about what constraints in a parametric drawing are. I'm going to demonstrate geometric constraints, dimensional constraints, how they're displayed, applying them, and then having them on all the time, which is inferring geometric constraints. As far as what are they? Constraints are parametric tools, and it provides a way of testing some of your design options while maintaining specific relationships. And a relationships there is a very good word. And I say that because typically AutoCAD, when we think of AutoCAD out of the box, there's not much intelligence going on, like our Inventor product or our AutoCAD electrical product or AutoCAD architectural. All of those softwares have specific tools that automate processes that we have to do. AutoCAD wasn't really built for that out of the box. Once they got into incorporating some 3D design inside of AutoCAD, constraints became part of that. So you're actually applying some intelligence to your drawing, which makes it, obviously very nice in a 2D typical AutoCAD environment. You're going to notice when I demonstrate, when I have some objects constrained together, linked together, when I change one, other ones will change automatically. And that's how I like to think about constraints. I come from the 2D world. I kind of compare this. I used to use an analogy way back when AutoCAD came out with layouts and viewports. It was kind of like taking a little bit of the 3D world into the 2D world with, draw everything in your model. When you're ready to print it, you create a viewport and a layout. Constraints, I kind of use that analogy. I'm taking a little bit of the 3D world and incorporating it into the 2D world. And we have several, as you're going to see when I demonstrate. Once you have objects that have been sketched, you can automatically and manually add constraints to the geometry. You can go about this, you can look at it two different ways. You can create your sketches with inferred constraints, what we call them. So as you're creating objects, the constraints where it sees fit come in automatically. Or you can sketch just like you've done all along, and then put your constraints in after the fact. As far as auto-constraining objects, like I just touched on, it enables you to automate the process of applying various constraints to multiple objects or single objects if that's what you choose. If you're working with rectangles or multi-line, multiple lines, polylines, you can use the auto-constrain command first to set up your parallel or your perpendicular, your horizontal, whatever constraints that you want in the relationship. I like to use the automatic constraints, especially if I'm drawing polylines, whether it's a rectangle, whether it's a polygon, or whether it's some weird shaped polyline. Puts them in automatically and I'm done. But again, you can always put them in after the fact. We also have dimensional constraints. Kind of think of this as after you get your sketch constrained, then you can add dimensional constraints to them. They control the size and proportions of a design. They can constrain distances between objects or points, angles, sizes of arcs or circles. As we know, in regular AutoCAD, if you draw an object and you put a dimension on it. If I modify the dimension, it doesn't touch the geometry. We preach that, or I preach that in my AutoCAD class. If you're going to dimension, make sure the geometry is 100% accurate. With dimensional constraints, the opposite is true. You're going to notice in my demonstration, when I change a dimension, that it will physically update the size of the object. Here's an example here. If I change the value of a dimensional constraints, all the constraints on the object are evaluated. They're affected, they're updated automatically. They're modified to reflect what you modify in the dimension. They can be added directly to segments within Polylines as if they were separate objects as well. And this is more of the inferring the geometric constraints itself. You can automatically apply them, like I've said, while creating and editing your objects. And it will automatically apply between objects you're creating or editing and the object associated with object snaps as well. And again, this is updating your objects. So it's linked. It's not just a dumb object with some dimension in there. Now, as far as object snaps are concerned, they apply only if the objects meet the constraint conditions. They are not repositioned as a result of the automatic constraints. With it turned on, the object snaps that you specify are used in the infer geometric constraints, but you do have a few that are not supported. Intersection, apparent intersection, extension, and quadrant. So again, in a nutshell, what are constraints? They apply intelligence to your objects. They link objects together. You change one, another one updates. You modify a dimension on one. The geometry updates per what you've changed the dimension to. So that's all I've got for PowerPoints. I'm sure you're all disappointed. But let me go inside of AutoCAD. And I'm going to start with just some basic tools as far as constraints are concerned. And then I'll graduate to an actual, part where you can see the relationships that update automatically. I'll do some of that here, but then it all comes together in this other drawing that I have available here. Now, as far as AutoCAD is concerned, you have a parametric tab at the top of your menu. Home, insert, annotate, blah, blah, blah. You have one for parametric. And on the parametric tab, I've got a geometric panel, I've got a dimensional panel, and I also have a manage panel. You're going to see how in the demonstration how we can manage constraints right through a palette essentially, and it will update all the objects that you've changed as well. So the first thing I'll do is on my geometric tab here, I'll go to auto constraint, and I'll just pick everything. It will put a constraint down where it sees fit. For these particular objects, as you can see here, it set up a parallel constraint on this line, a parallel constraint on this line, and a horizontal one on this line. Now, let me undo this, and I'll apply these constraints manually this time instead of automatically. I'm just going to go up and undo my auto constraint. And I'll start with, up here, we have a concentric one, where I can select circles, arcs, ellipses to maintain the same center point. So I'll select my first circle for the large circle first, followed by the second circle. Now I've constrained them to have the same center point. And you're going to notice a pattern here. The second object you select every single time is the one that moves, the one that changes size if it needs to. So I kind of figure whenever I have to select an object, I think of the first one as my master. Now I'm going to go up here and select a parallel. It constrains two lines to maintain the same angle. And I'll pick the vertical line here on the left first, followed by the one on the right. Now, just like I did when I auto constrained, but notice that these two are now linked together. I got the parallel here, I got the parallel here. I hover my cursor over the little icon or tooltip, whatever you want, the badge, whatever you want to call it here. And you can notice that both of these highlight at the same time. Now I'm going to select a perpendicular one right up here. And this constrains two lines or polyline segments to maintain a 90-degree angle for each other. And I'll pick the vertical line here first. And then the second one down here. Notice the second one. It matched the first one. So now those two, and as you can see, what's linked together. Now, I'm going to select the parallel once again. Or actually this time, I also have a horizontal and a vertical up here. As you can see, a horizontal constrains a line of pairs of points to lie parallel to the x-axis, and the same with the vertical. I'm going to select the vertical. Now if I pick this line on the left, notice that all three of these just updated because they're linked together. That's the whole point. This is what constraints are. They apply intelligence to your objects. It forces the one on the right to be vertical as well, and the one on the bottom for that matter. Now I'm going to go back to parallel. And I'll pick this line on an angle here first, followed by this one here. Now, as you can see, those two are linked together. Now I'm going to select the equal. These constrains two lines or polyline segments to maintain equal lengths, or arcs and circles to maintain equal radius. So I'll select equal. And I'm going to select the vertical line on the left here, and then this angled line up top. And it's difficult to see, but the second one did change in size to match the first one. Now, some of these are some of your more popular basic constraint commands. We also have, and I'll use some of these in the second demonstration, collinear. We can fix constraints together or lock them into place. We have tangent, which takes two curves to maintain a tangency to each other. You've got smooth for splines, lines, arcs, polylines. We have symmetric, which are curves or points of an object to maintain symmetry. You can use any of these just depending on what it is that you're trying to constrain together. Now this time, on my status bar, if I go to the customization tab down here in the lower right corner, I've got everything turned on. You might not, as far as it being displayed on my status bar, but notice we have an infer constraints. Now down on the status bar, here is the constraints button. Right now it's set to off. And just for the heck of it, I'm going to leave it off. I'm going to show you what happens when it is off, which is normally how you, if you've never used constraints, it's probably how you're working right now. So just for the heck of it, I'm going to go up to the Home tab, and I'm going to draw myself a rectangle, any old size. No constraints come in. I'll go to a polyline command, and I'll draw some weird shaped polyline, let's say. Just put anything together here. Come up here. Still use all your standard drafting features. And let's say I close this out. So I got a polyline. Rectangle is a polyline, as you know. Nothing's constrained at this point. I'll draw some lines. Regular old lines. Put something on an angle. Maybe a couple angles, whatever. So nothing, as you can see, has any constraints in it. Now, just like I did before, I could go to my Parametric tab, pick Auto Constrain, select everything, hit Enter. Where it sees that it needs a constraint, it'll put it in there. Now, having said that, I'm going to undo all this stuff. And then I'm going to turn the infer constraints on. And I'm going to do the same exact thing. I'll go back to the Home tab. I'll pick Rectangle. And I'll draw myself a rectangle, a polyline. All the constraints are automatically applied. I'll draw another goofy shaped polyline. You're going to see as I draw this, the constraints appear where it sees fit. And it doesn't matter what I put in here. It's going to drop the constraints in automatically because I have the inferred constraints on. It's basically automatic constraints. Unlike when I did that the first time. Now, when you have polylines, as you can see, it figures out real quick what, potentially you want constrained together. Because in a polyline, as we know, all of those lines are automatically connected together as one object. Now, if I draw, just regular lines, if everything's at a 90-degree angle, it puts constraints in automatically for me, as you can see. As soon as I go off on a different type of angle, you can see it doesn't automatically put them in because it doesn't know what you want to make parallel, to make perpendicular, what have you. So that's where you would go back in, put the constraints in there that you see fit. Now, if I just draw a circle, I have the inferred constraints on. And then I'll draw another one. And let's say I line this up right smack dab in my center of the previous one. Now there's a constraint on there, as you can see. It's tough to see in the beginning because this doesn't show up automatically, but it is there. Now let's say I didn't know that it was there. I'm going to go back to my concentric. I'll select the first one, and then I'll select the second one, and I'm going to get this alert. cannot be applied, it conflicts with existing constraints or would over constrain the geometry. No reason to panic when you get this. It just, means you already have the constraints in there. Now, as far as the equal with circles, if I draw another circle, and then I'll select the equals once again. I'll pick this circle, followed by this one. Now these two are tied together, as you can see. They're not centered, because that's not what I wanted. I just wanted them the same size, and now they're linked together. I change one, the other one updates automatically. So these are some of your basic constraint commands. Now, the next part of the demonstration, I'm going to show you how, after you apply constraints, how when you modify them, how it can affect, similar to what I did in the first one, but even more so here, how it can affect other objects that you have constrained to them. So here's an example, let's say, of a typical part. I'm going to add some geometric constraints and some dimensional constraints to this object. And just like I did in the first example, the first one I'm going to do is I'm going to auto constrain this. And once again, I'll select everything. And it puts the constraints obviously where it sees fit. Now, I'm going to pick this top horizontal line. No command running. I'm just going to use a grip to move it. You can still use your grips even when something's constrained, just like you normally would. So let's say I take my middle grip and I just kind of move this out to the right, something like this. Everything that was constrained together will be updated automatically, as you can see right there. But it's not constrained enough to keep it from distorting, because obviously this and this, we have an issue. This arc and this circle. Nothing was constrained together, so it's not like it updated automatically. So now I'm going to hit escape here. And the next one I'm going to apply is a coincident. I'll select it here. And then I'm going to pick the arc located right here. And then I'm going to pick the end point of the line right here. Now I've got those two constrained together. Look what happens to all of the objects, everything except the circle, because it was all tied together in some way, shape, or form. Everything updates automatically. This is the power of what constraints can give you. Now I'm going to add a tangent constraint to the arc in the coincidental line. So I'm going to come up and select my tangent constraint. And I'm going to select the arc that I just did in the previous step and the same line. Now I have another tangent constraint in here. Now to make the same line parallel to the line above, I'm going to select the parallel constraint. And I'll pick the top line here, followed by the bottom line down here. Watch everything update automatically. And remember, the second one is the one that gets affected. Next one I'm going to do is go back to the equals. So I'll select the equal. And I'm going to pick the, let's see here. Hold on just a second. Forgot one step here. Hold on. I'm going to go back and select perpendicular. And I'm going to select the top horizontal line here, followed by this line here. Now, I'm going to go and select the equal. And I'm going to select that same vertical line on the right here. Followed by the one down here. And you can see the object taking shape. And this is the other thing you want to think about if you have constraints in mind. Draw your objects, give it a first shot, because you know you're going to be making changes to it later on. And you know when you change one, another one that you have constrained to it will update automatically. So it's one of those, don't fret so much about the geometry in the beginning. Don't try to get it perfect, because you know full well you're going to apply some parameters later on with the constraints that will update everything automatically. And that just goes back to how we use constraints in a parametric drawing. Now let's make the two arcs equal. So I'll select equal again. And I'll pick this arc here, top one. Let's pick the bottom one first, followed by the top one. Now I'm going to go back to concentric to have the circle in the top arc share the same center point. So I'll go back to concentric right here. And then from here, I will select the arc first, followed by the circle. Now they share the same center point. Now I'm not going to worry once again that my circle is moved outside of the arc. We're going to fix that very shortly. Now I'm going to select the bottom parallel line here just to display its grips, and I'm going to pull the middle grip slightly down so now the circle fits inside. So essentially I'm going to pick my middle grip, and I can see if I move it, let's say down to here, that now the circle fits back inside of there. I'll hit escape to clear my grips. Now, if I want that circle to be a fixed point, I can use the fix constraint. So up here we have the fix, and I'm just going to select the circle. Now, as you can see, it's got the little padlock on there, let me know that it's a fixed point. So now I have all these constraints on here. The geometry, as you can see, there's not much precision going on right now. And again, I don't care about that at this point, because the next thing I'm going to do is add some dimensional constraints. That's where my precision is going to come into play. And before I add the dimensional constraints, I'm going to hide all the existing geometric constraints. So all I have to do is say hide all up here on the geometric panel. They're all still there. Not like I deleted them. They're just hidden in the background. Now on my dimensional panel here, I'm going to start with a linear dimension. Just like if you were to dimension regularly, you know, I can choose the object option just to select on my object. I could pick it here, or I could just hit enter on my keyboard. And I'm going to select the vertical line over here on the right. And like I said, not a lot of precision going on right now. That dimension is 1.0541. Now, having said that, instead of it being 1.0541, I'm just going to type in 1 and hit enter. And notice it didn't just change this, it changed any of the other objects that were affected by my constraints. I go back to objects are linked together. So now I'm going to put another linear down with my object option. So I'll just hit enter this time, and I'll place one down on the horizontal line right here. Draw this one up to here. And once again, I'll type in 1. Watch everything update, or whatever's constrained together. Now, on the next one, I'm going to choose the aligned dimension. And I'll select this line right here. Oop, forgot to hit my objects first. And let's say I drop it in right about here. Now for this dimension 3, instead of it being 2.3085, I'm going to call this D2 plus 1. You can include formulas in constraints. Hit enter. That's what that particular dimension now is. Now, this is where it, really, and you'll see this, you longtime AutoCAD users or your power AutoCAD users, as we know, if I were normally just to change a dimension, it does not update the geometry. Well, with constraints, it does. It's the complete opposite. So if I double click on my dimension, and this time I type in 2, and I hit enter instead of 1, watch it update and anything else that it is constrained to update at the same time. That's what you're not going to have without constraints. That would not change any geometry, as we all know. If it's regular AutoCAD and your dimension's wrong, it's time to fix the geometry. Here, I can adjust the geometry based off of what I plug in for the dimension. I'm going to hit escape to get out of the edit text or edit dimension, if you will. Now, let's go to our radius. And I'm going to pick the arc on the bottom here. And I'll just drop this into place right here. It's fine. And once again, instead of having it be 0.8234, I'm going to type in a precision of 0.5 and hit enter. It modifies the geometry. Let's do an angular one next. We'll go up to the angular. And we'll pick this horizontal line here, followed by this angled line here. Now in this case, it's 120 degrees. I'm satisfied with this. This is what I wanted it to be in the first place, so I'm not going to change it to anything. I'll just hit enter to accept it. So that's how you can make modifications to the dimensions and have the geometry update automatically. Now we can also do the same thing through what we call, I mentioned it a little bit earlier, our Parametric manager. So it will list all of your constraints right there, your dimensional constraints. Any changes I make here will affect the geometry as well. So as an example, for the angled one that I just accepted 120 for, let's say I change this to 100. Just got to type in 100, hit enter. Now that angle changes. That angle changes. Anything that's constrained to it gets changed, as you can see. Say I make it 150. Watch it change again. This is the beauty of constraints in an AutoCAD environment. Now I'm going to create a user parameter. So from my manager, we have this create a new user parameter. And I'm going to call this base. And for the expression, I'm going to go with 1.5 and hit enter. I haven't applied this to my geometry yet. That's why nothing has changed in my geometry. Now, having said that, let's take this D3 and I'm going to change the D3 to D2 plus 1 plus base and hit enter. Now it had adjusted my geometry accordingly. I could continue to make changes to that, if I wanted to, any of these. Let's say I take the D1, the first one I placed down. Maybe I make that 2. I could change the D2. I could change the radius of the arc, whatever the case is. I'll do it again. My geometry will update accordingly. That's the power behind the constraints. Now I'm going to shut my constraint manager off. And then I'll go back to the geometric tab. I'll pick show all. So now I'm showing everything, my geometric constraints, the constraints themselves, or the dimensional constraints, the geometric constraints, everything's on display here. Notice how it's on display. So this says D3 equals D2 plus 1 plus base. D2 equals 2, D1 equals 1, so on and so forth. We can change the appearance of that as well. So on the dimensional tab, we can go to the manager, just like you do with a lot of other managers in AutoCAD. Here's the constraints settings. So if I start at the geometric tab, let's say I turn the tangent off, just for the heck of it. Then I'll go to the dimensional tab. And I'm going to change this, instead of the name in the expression, I'm going to change it to value. Watch the appearance of my geometry change when I pick OK. So now they only display the value in the tangent constraint is no longer displayed. And it doesn't give me the D1, the D2, the D3. It just gives me, like you normally would, dimension something, right? Like you do in AutoCAD, regular AutoCAD. Now, the last thing I want to show you here is you can also convert regular dimensions to dimensional constraints. So as an example, and I'm going to turn my inferred, I'll leave those on, I guess. I'm going to go back to my home tab. And I'll go to my rectangle command. And once again, I'll just draw a rectangle any size I want. Puts all the constraints in. I'll draw a circle. Then I'm going to go to my annotate tab. And I'll start with a linear dimension, straight up linear dimension. And then I'll also drop down a, let's say, diameter dimension on the circle. Then I'll go back to the Parametric tab, and we have this convert. I'll select my regular dimension, both for the line object and the radius, the linear and the radius. And now I've turned them into dimensional constraints instead of just straight up dimensions. And just like I did over here in this example, you know, maybe I want to change this from 1.6293 to 1.75. Geometry updates automatically. Maybe I want to change this to 2. Geometry updates automatically. And this goes back to my whole point about constraints and why you would use them. Now, obviously, as I was just speaking to Dan before the webinar started, you know, if you're using Inventor, this stuff is almost automatic. You know, it's considered part of the software itself. And I'm not an Inventor guru, but in AutoCAD, you know, it's not an add-on. It's built right into AutoCAD. This is straight up AutoCAD with no tool sets, you know, but it's a tool that you can apply intelligence to, where you can link one object to another object to have it update automatically. Like I said, in the 3D world, you know, this stuff is just second nature. You're used to these tools. In AutoCAD, not so much, but they are available when you need them there. Okay, that is our 45-minute webinar of constraints. I'm sure Dan has been answering questions. We can take a look at those questions, try to get as much as we can answered. And if we can't answer your questions, then obviously we will get back to you. So let me just take a peek here to see how Dan's doing on the questions. Looks like he's got them all handled. I'm just reading through some of these questions now right now. Like I said, it looks like Dan has them all answered, at least in the GoToWebinar portion of this. And I'm sure as Ashley's going to chime in here soon, we have this recorded, and if there's anything that we couldn't get answered, obviously let us know and we will absolutely get back to you. Ashley, you want to chime back in, or?
Yeah, yes. If you think of questions later on, you can simply reply to that confirmation or reminder email you received from GoToWebinar, and we can get those to Greg or your sales rep to get those answered. We will go ahead and shut down today, but thanks for attending and have a great day, everybody.
Thank you.